Okay, so picking up where we left off, this is just going to be me finishing these notes quickly. The question C says, does more or less than 50% of the data set fall within one standard deviation of the mean? Well, we know that it's approximately supposed to be 68%, so hopefully it's more, but we don't know because we have to actually look at this actual data. Remember that 68% is only an estimate. So given that our average is 42,060, okay, one standard deviation above it would be me adding 16,736 onto it, which would be as high as a $58,796 salary, or as low as, if I subtract that standard deviation away, $25,324. So who falls between $25,324? So not these people, they're a little bit low, but all of these people up until $58,796. So all of these people, that's 35 plus 7, that's 42 out of 50, which is 84%. So much higher than 50% actually. This one's actually it's worth noting, far off from the 68% average. That usually 68% fall within one standard deviation of the mean. But it just happens with these numbers that that's the way that it actually occurs. Jumping down to exercise 4, we have a questionnaire that went home to all juniors concerning their ability to bring and use mobile devices at school. The questionnaires constituted a census since all of the juniors were surveyed. So this is not a sample of juniors. We are surveying all of the juniors. And when you are surveying all of the juniors, you are addressing the entire population of juniors, and that's what makes it a census. So of the 742 juniors, 564 of them reported having web-enabled mobile devices. So this is called the population proportion, not the sample proportion, because we didn't take a sample of juniors. We took all of the juniors. So if it's all of the juniors, this is the population proportion. So the proportion of the population that actually had web-enabled mobile devices was 564 out of 742. That's the population proportion. Express your answer as a decimal, so I would do that division. I'm probably going to have to round it. This is 0.7601 as a decimal, and then as a percentage, that's 76.01%. So just based on where I cut off the decimal, I ended up, the decimal is to the nearest 10th, 100,000th, 10,000th. So I happened to make that one to the nearest 10,000th, and that made the percentage only to the nearest 100th. Exercise 5 tells me that the proportion of eggs that get cracked in a local egg handling facility is 0.023. So that's just for the sake of getting a grasp on that. If I move that decimal place over for that proportion, that means 2.3% of the eggs get cracked. Now, 2,500 dozen eggs are packed per day. 2,500 dozen is how many eggs? 2,500 times 12. 12 in a dozen. 30,000. So out of the 30,000 eggs per day, what should we expect to be the number of eggs that gets cracked? Well, 2.3% of that number. Of in math means multiplication. So there's our 2.3% as a decimal of 30,000, and that'll give us our 2.3% of 30,000, which is 690 eggs. Option 4. Okay. Down here at the bottom, I'm further stressing the importance of the population parameters or the population statistics versus the sample statistics. Now, in real life, it's very rare that we can take the entire population, let's say of the U.S., for example. It's very rare that we're going to get data from an entire population. And in those cases, we will always be calculating the sample statistics. So we can only at best get the average of the sample that we choose, or the median of the sample that we choose, or the standard deviation of the sample that we choose, knowing that that sample of, let's say, 100 people is trying to represent a population of over 1 million. And that's where we use sample. The only time we can really truly get population parameters is if we take that small company example from above. If we know the company only has 50 workers and we survey all 50 workers, that's a population because you're doing the whole company. In exercise 4, we do have population parameters there because we've surveyed all of the juniors. Now, we could easily turn this into a sample situation. If we didn't want to survey all 742 juniors and we only wanted to pick 50, then we could find the average of the 50 and all the information about those 50 juniors, and it would be a good estimate for the entire population, but it's not the exact population's statistics. But samples still give us an approximate. They're obviously off a little bit from the full population statistics, but they do give us nice estimates, and it's just easier to collect a sample versus tracking down all 742 juniors. So we'll be talking about populations versus samples a lot, and how to use samples to make generalizations or to make predictions about a population.